Am I audible?
Yeah, yes.
Okay, so yeah, I hope we can start the session. It is already 16. Okay. So in the previous session we have seen how to write some APIs and how to something like saving some values, like how we can save some values. Also like how we can read some values from the server and how we can show it to the like how we can do those kind of activities. And we have seen like what is kind of a API and how we can do those stuffs on that. So any doubts on that, like on the previous session we had? Okay, I hope there is no doubt. Okay. So also like we thought to give you a small task on this one, like on the Python. Okay, so I will give you what is like overall view of what the task is going to be. And after this call, maybe I will share you like a kind of a document or something like kind of a notes, like how should be the inputs and how should be the outputs and all. Okay. So the task is something similar to a kind of a ordering app or something similar to that. Don't like imagine something like Swiggy or something. So not that kind of big. Just kind of ordering app in CLI. Okay. So the task which we thought to give off is like it is going to be using an Domino's or some kind of a shop. So okay, so when you start the program, right, it should show like what are the types of foods which are available in that shop, and also like how many quantity are available for the each item, and how much each cost. Let's say like if it is like something like kind of a Domino's, you can say like, oh, these are the pizzas available, and these many pieces available for now, and one pizza's cost this much of money. Okay, so something like that you can show it in a CLI. Okay, and then you can ask from the user input, stating like what are the things he wants. So how many items he wants, like or like if he wants pizza, right, like he wants like how many like let's say he wants a regular pizza, like then how many regular pizzas he wants. If a pizza's cost 100 and he wants two of that, so his total bill is going to be 200. Okay, so you need to cross validate whether the two pizzas are available, and then you need to tell that this much is your billing cost. So let's say like it is 200 for now. Okay, so you need to show in the CLI stating that this is your billing amount. And then the let's say like imagine it is a real world scenario. Okay, the user will give some amount of money to that cashier, or like kind of a guy who is going to sit in front of that billing system. So let's say if user is giving 300, so like you need to input a 300 in that CLI, so in the command line, so in the CMD. And then what you can read that input or 300 from the CLI, and then you can say like your bill is 200 and the remaining balance is 100, like that you can print. Let's say if he is giving lesser amount than the billed amount, then you can say like you have entered less amount, kindly give and kindly enter the like give the amount which is higher than the minimum amount required, something like that. So clear, like if you have any like doubts on this one, this is the task. Maybe within like next week we can see how you guys are doing on this one. So I will give you clear documentation, like a kind of a stuff, what are the inputs and outputs should be, how it look like on that. Before that, any doubts on like this one? I hope it is clear.
Yeah, it is clear.
Yeah, fine. Okay, so then yeah, if that is also clear, so we can move into our topic for today. So right now we have seen how you can write a kind of a UI, and we have seen how you can write a kind of a backend. So how you can write your APIs, and right now we want to see like how we can store our data to like reuse after sometimes. Let's say you like we'll take the same example which we talked now. So we want to like save our let's say I'm going to but I'm using a Swiggy, so I need to see what are the previous order I have, right? So in that case what I can do is I can get what are my previous order if I saved it into some kind of medium. Okay, so over there, like we want the saving function to just retrieve the amount back. So take example of bank. So in bank, right, you will go and put money. So if you are writing a software for a particular banking system, you need to save what is the balance of this guy and how much he deposited on yesterday, like previous month and other things, so that he can view the statement of his things and his account, and he can see like what are the how much money he puts in and how much money he gets in, like that he can get from the statement. So for this, right, you need to save the data first into a system so that you can retrieve back after some times. Okay, so for this saving, which we saving kind of things, we need to go into a database. So this is where we need a kind of database where we need to save our data which we got from our system, um, to for our further use or kind of some kind of calculation for the further use for the future use. Okay, so this is why we need a database basically to store the data so that we can use it in our future. Okay, so databases can, like, you can store data in any, like, in either in a file format or into a memory, or in a memory or some kind of formats. So most popular is like, there is also a file DB which you can write into a file. Let's say like you just take a txt file and you can write what are the all data into that, and you can read from the txt file. So that is also fine, but that won't be good enough when you, let's say, when you are running a huge level bank, let's say like a kind of international bank, you will have so many accounts and there will be so many transactions will be happening for each and every day. Okay, so many guys will be transferring money from one account to the next account. Okay, on the scenario, if we went with a file DB, right? File DB is something like, take a plain file and write everything into a file, which is similar to what we are doing in a notebook, writing down into a notebook, like a handwritten notebook, right? Similar to that. So if you want to search something, let's say like I did a transaction to Harun. Okay, so in that case, if I want to see what is a transaction, last previous transaction to Harun, so I want to read the whole file line by line and to get the details. So this is why, like, this is what the main drawback of going with the file kind of a DB. Okay, so storing into a file is not scalable, which means for your each and every executions it will take a lot of time. You need to go read line by line, and then you need to check it out. Okay, so this is why most of the cases, like if it is database is going to be a huge database and large number of data is which you are going to save, then we don't go into a file database kind of system. So where in the case we'll go to two major, there are some major, like there are different type of DB, like kind of RDBMS and something of non-RDBMS DBs and some graph DBs, in-memory DBs. These kind of DBs are there. So most popular and most very popularly used DBs are like something similar to RDBMS and some kind of DBs like MongoDB, where it is like object-oriented DB. It is not a relational database management system. Okay, so let's see what is an, like, I will give you a little intro of what is an RDBMS, and then we'll go into MongoDB, which is we are going to use here. Okay, so first, how many of you knows about little about RDBMS? This
Yeah,
could
I know the basics.
Yeah, okay, this could have come already in your syllabus, right? So basically, you know what is a relational database management. So everything which you are going to save it as tables and rows, and there will be some relation between each table. So let's say like you have a student table and you have a mark table for respective student. So in the mark table, you will maintain all his marks and other things. And student table will contain his student details like what is his address and what is his enrollment number, age, and other stuffs. So you will have something similar to that is called as RDB mesh or relational database management system. Okay, here you normalize the DB and make it into subtables, and you will put so much of joins to query out the data, and you will do all the steps over there. So you are clear with that, right? Or do you need a little intro, like a little overview or summary on that? If you are clear, we can see like how Mongo is different from RDBMS. Uh, did you understand my question?
Give some summary about that.
Okay. So yeah. So how will you write? Like you at least you know a little about what's an RDBMS, or like basically I need to from start from scratch, something like that. Okay, I will take it. Not a problem. So imagine like you want to save some data. So in RDBMS, right, it is a relational database management system. Over there, what you'll do is you will create tables. So tables is a set of rows and columns. Okay. So you will create table for each and every items. Let's say you want, let's say your college is there. So first thing is you will create a student table, and in the student table you will have all your student details, something like your roll number, your address, and other stuffs. Okay. So, and then you will have something table kind of as like your attendance. It is going to be in a separate table, and your marks. So your be for each and every semester, right? So your marks is going to be in a different table. So it is going to be again a different table for marks. It will contain again rows and columns. Okay. So those rows and columns will have columns. Columns is like your fields. Like what are the like if you take a student data table, you will have fields like name and what is your age, and let's say like what is your address, and then you will have something like what else you can have in over there in the student table. So whatever you fill up the form when you are joining in your college, right, you will it those all things will comes under the your student table. Okay. So then what will happen is you will have two or three tables. So you will do normalization on the top of the table so that you can remove duplicate records. And then once those things are fine, right, you will have a separate table for your marks, and you will have a separate table for your student. Okay. So from a student, how you map to your let's say you have a student table and you have a mark table. So from the student, right, your ID will be there in the mark table. So using that, you can find out what is your mark in your student table. At least clear with this one.
Yeah, yes.
Okay. So just give me a minute. And is my screen is visible? I hope it is visible.
Yeah, it is visible.
Yeah. Okay. Fine. Thank you. So let's take these are your two tables. Okay. So I don't have any visualization for. So I will go with paint. Okay. And this is your student table, and this is your mark table. Okay. So you will have something called ID. So ID is why we like I will tell you what is the need of ID, and you will have something like a name, let's say name, and each these and all your columns. Okay, there will be each and every rows, and there will be something like ID equal to 1, and let's say my name, just this one, and this is for name shake. And you will have something over here like this is my mark table. So in my mark table I will have like a mark 1, like these are my subjects. So mark 2, I'm just making a swim M2 M3. So you can relate it as max 1, max 2, max 3 paper or something like that. Okay. So these are my marks. I will have my marks like 80, um, mm, something like 15, something like here. So this is my one of my table, and this is one of my table. This is how typically RDBMS look like. So you will have all your tables over here. So each table will contain rows and columns that is going to contain the records. So if you save the records over here, right, either like if you want to see my results. So what I can do is I can take the name as Rahul, and I will have my enrollment number, right. So my a number, just let's say like 101. So I will using this enrollment number. What I can do is I can take out all these marks which is scored in the last semester. So something like that we can do. So how this is going to happen is, right, here you will create a mapping. Okay. So the mapping is like you will create something called student ID. This is SID, means student ID. So my student ID is equal to 1. So I will have 1 over here. So this is going to map with the ID of this one. So I will come to ID now. So ID is like a unique identifier for the particular table. So ID is not something like unique, which is not going to repeat for some other student. Let's say some Ragul 2 or Ragul 3 or Ragul 5 is going to be there. So his ID is not going to be same. So maybe his name is also going to be Ragul, but his ID is going to be 2, and your enrollment number is also going to be like a different. So over here, what I can do is I can using this ID, I'm going to map this one, and then I'm going to take this record, and then I can show it to the user. So if you can see right now, there is a relationship between this one. So for this one, like for this row, there is a relational row between here. We are mapping this only using with this ID. So with this ID, we are mapping to my name, and from here we are getting this. This is how RDBMS will work on a overview, like a summary. Any doubts on this one?
No doubts.
Okay. So uh, if you see right, if you go into non relational databases, something like a kind of a Mongo, over there what we don't need something like a kind of a table. So we don't need this table, and we are going to save the documents, like we are going to save this as a document, something kind of a similar to a JSON structure. Okay. So the first thing which we do basically when you are reading some data from the table is, right, so you will have n number of columns. We'll have, let's say, like 10 to 20 number of columns, and then basically like most of the queries will be select star from. So you take mostly all the values from this one, and how it is going to fetch the value from the databases, right? So it is going to store in your HDD hard drive. So it is going to stay into your hard drive or hard disk. So what will the file reader will do is it will come to this column, and it will take this one, and again it will go to the name, and then it will read this Ragul, and then it will go to the age, and then it reads 10, and enrollment number it will read this 110. So so it will go and like move this read write head on the disk, like on a particular typical HDD drive, to a particular columns, and then read this particular values located in that HDD. So if you see, right, the basically the time for reading this one is very large. Okay, but and comparing to like very large, because the whole data is having so many columns, and you need to move your disk for each and every time to read this column. Okay, so and this is one of the reason. And if you see here, there are like a lots of joins are happening. So if you want to read the mark of mine, let's say mark of these three subjects, what you need to do is you need to first fetch this enrollment number, and then you need to take this ID. From this ID, you need to map into my mark table, and from my mark table you need to read these three values. So to read these three values, we need to do one read here and the next read here, and it should come here, and it will take the values from here. So if you are having lots and lots of join, it is going to make your DB slower. Okay, so in that case we can go into something kind of a non-relational database management system, like something kind of a DB of that. Okay, so let's go into like how a MongoDB will look like. So this is a MongoDB Compass UI. Okay, this is a Compass UI. So you can download and install this one. This one is free, and you can use it for this one. Okay, so what this like if you download and install this one, it will run a MongoDB server on your local host 20 on your local host 27017. Okay, so if you open this one, it will be something similar looking like this, and you won't have the sample one. We'll have admin, config, and local. Okay, leave this three. So this is how typically a MongoDB UI will look like. Okay, this is like a user interface where you can do all your creation of tables and creating your records, like inserting elements and other stuffs. Okay, so I will show you what I have sample created now. So this is how a student table will look like in an RDBMS. So if you come to MongoDB, in MongoDB, this is how it will look like. It will have something called as name. I have age, and I have my marks, and I have my class. So if you see here, it is like something similar to a JSON, like kind of a document. So it is something similar to kind of a document, and it is something similar to kind of a JSON. So this is how a value will sit, like this all will sit together into a kind of a JSON. So this is how it will sit in a kind of a DB. Okay, so now what will happen is, if you are going to read this particularly my name, So it will go and read this whole record, which is going to be sitting at the same place in your HDD. So if you do select star in this one, the read time is going to be very, very less when comparing to the RDBMS, because in RDBMS, right, you need to change your header into this particular row and you need to read this column name, and then you need to read this column value, column name, and column value. So right now we are having only one record, so it will be similar easy for you. Imagine something like you have a 1 lakh records in this one, and you have 1 lakh one record here. Now you need to change, you need to move your thing from ID, and you need to read this value, you need to read this name, and then you need to read like this. So the disk like kind of a read write is very, very like some kind of slow when comparing to some kind of like this kind of MongoDB. So this is one of the advantage. And here, right, you need to specify your schema. So let's say I have M3 M4, and I have like until M4 I have here. Suddenly what they are doing is what is happening is suddenly they are adding one more column, like one more subject to it, this one, so to the syllabus. So what I need to do is I need to add one more column over here. So to, right, how tough it is to add a column. Because if you add a column, right, you need to, let's say you need I why this is playing with me. Okay, okay, you need to add one more column. In that case, what will happen is you need to create one more column, something similar to this. Let's say we call it as, we will call it as M4. Okay, so this is going to take, you need to, if you add like M5 something kind of this, you need to insert this records for this case. So either you need to insert 0, or you need to insert some kind of default value for each and every record which doesn't have this value for this one. Basically each and every row should have each and every column values. So if it is not there, it most probably it will throw an error. So most of the time it should not be non-nullable values, because at least there should be some default value of 0. So if you want to change your schema of your table, like if you want to change, add one more column or remove one more column, or like kind of stuffs like that, so using this RDBMS it will be too hard for you, because you define a schema, you work on that. If you want to add one more column, you need to run the alter table command, and then you need to run the update command for each and every row, so that the default values will be populated for each and every row. Okay, where in the case of Mongo, right, in MongoDB, what you can do is you can have like, now if you see here, this column is having the name, like this particular document. So here we call it as row, and here in MongoDB we call it as a document. So this document, if you see, we have a name, age, mark, and class. If you see this second document, which is the second row, which has only name and class. So you can have any schema, like the schema is going to be very user friendly. You don't want to define a schema. If you want, you can define some kind of validation, but you don't want to define at the first. So whatever the values you can put it into here, you can save it here. So if there is no column, like there is no value for this particular column, you can leave the column name itself, so the column name will not come. So again, in the next one, you can have something similar to this. So now if you see, my column names is going to be here like a static, it is not going to change. If you want to change, it is like a whole change in your system. It will affect the whole database, and it will take a lot of time to reflect. But in the case of Mongo, you don't want to do those stuffs. So your schema is like dynamic, it is not defined. So everybody clear with this dynamic schema thing? Or do I
Yes,
need
it's
to?
clear.
Okay, so this is one of the advantage of going with a non-RDBMS DB. Okay, and your read is going to be a little faster, and your things like what you can say is your schema is not defined, and you don't need joins over here. So basically, you don't need by any kind of joins over here. What you can do is you can have C, right. You can see, right, my mark is something like a kind of a list object, and you can have one more object inside over here. That is also possible. That we'll see in the later session. So you can have like kind of document which is going to have a list of values for you. So when in the case of this RDBMS, right, most of the RDBMS doesn't support list of records. So if you want to save mark, you need to do this normalization. You need to separate, or you need to save it into a separate table, and it is going to cost you a join. Where in the case of here, you don't need a joins. So the data, right, you can put it inside. So like if you can see here, right, my mark is having 11, 20 and 99, something like that. You can save it directly. So in RDBMS you need joins and other stuffs, but in this one MongoDB you don't need a kind of a joins. And I hope you are clear with what is a join. If you are not clear with what is a join, I will explain you that one also.
Can you please explain again?
Okay. So let's say I want to read the values, like read the mark values for this particular enrollment number. Okay, so the user is giving particular enrollment number as 101. Okay, for this 101, what I need to read is I need to read all the mark values, like what is this mark for this particular semester. Okay, so what we have to write query is select star from student where enrollment number equal to this one. If you read this one, and you will get this student ID, which is saving into here. Okay, using the student ID, what you need to do is you need to take the mark from here. So this student ID is going to link here. Okay, clear with this one. And using this one, we need to read this 80, 10, 15, what are his marks is going to be for this particular subject, right? We can read it from here. You are clear up to this?
Yeah, it's clear.
Okay. So now what you are seeing, right? You can see we are doing a join. So this table is going to join with this table. Yes, right? So basically you are telling, so from this enrollment for this enrollment number, what you are getting, this ID is going to join with this SID, like the mark table SID, the student ID. And if you put a join, you will get all these records. So for my name, my marks of 80, 10, 15 and something, you can say like some kind of a 8 over here and some 0 is there. Okay, this is how you do a join in RDBMS to get records from different tables. Clear until now?
Yes.
Okay, so if you come to kind of a MongoDB, so if you see here, right, I will go into a table structure. Okay, so now this is my student table here. Okay, this is my name, this is my age, and if you see here, this is my mark. Okay, now if you see mark is going to be something similar like kind of a list. Okay, so you don't need to query it out from, like you don't need to put this joins, where in the case you can save everything into your particular column, so you don't need this join itself. You can have a inner documents over here. Clear?
Yes, sir.
And I'm doing screen sharing, and
Yeah, your screen was shared.
it's shared, right? Okay,
Yeah.
okay. Because I got a little afraid whether. Okay, so you now you are clear with why we don't need a join in the case of MongoDB. So this join, what is going to cost is it is going to definitely reduce your read time, because you are going to map this one record into this table. Right now we are having only one record in this example. In the real time scenario, right, at least you will have 1 lakh records. So if you want to join 1 lakh records and read the values, it will cost a lot of time. Okay, so when in the case of Mongo, right, you will have everything into here. So I will change into this kind of structure. So you can directly read from here. So this is going to be a single read for you. So the read is going to be very, very faster when comparing to your normal RDBMS. Clear with this one?
Yes, it's clear.
Okay. So this is one of the advantage when going with the Mongo kind of a DB. Okay. So now what else is there? And there are some stuff like I will tell you, like don't go deep into it. Basically you don't need it for now. So scaling of a DBMS is very, very tough. Okay, scaling in the sense means making it available for a large number of users. So let's say you are going to write program for Amazon or kind of a Flipkart. So your users are very, very high. On a particular time, maybe hundreds and thousands of users are going to use Amazon and your particular Flipkart. Okay, in the case of that, if you have a RDBMS and if you want to scale up, we talked this topic on the API, right? On a day of Big Billion Day, what we can do is we can create one more copy of an API, which is respect, and that by that we can solve this problem like that we told, right? Which in the case of RDBMS, which is very very tough, where in the case of MongoDB we can do those, like we can have a replicate DB, and like those kind of things are available. If we go deep into it, it is not needed for you now. Just remember that scaling is very 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 easy when comparing in MongoDB when comparing to an RDBMS. Okay, for not have it like that. If you want to scale up for a number of users, you can do easily on MongoDB. And in the case of RDBMS, it is little difficult to do that. Okay. And apart from that, what is the difference? Yeah, basically these are the difference. Okay, so next, where to use RDBMS and where to use your MongoDB. Okay, so if you are going with some kind of a banking application, you should go with RDBMS. Okay, no matter what is your scaling and other stuffs. Okay, so you need to go with RDBMS. You should not use any kind of a document-based system. Okay, these are not too good for a banking application. Okay, remember just like that, if you're going with some kind of banking application, you should go with RDBMS. And where should you go with the kind of a documents, this kind of object stable, like kind of a MongoDB is like where you don't know the schema. So what is your table schema? If you don't know, you can go with this one. And if you want to give for a high availability, like kind of a large number of users are going to use your application, in the case you can go to MongoDB. And if you're having more of reads than writes, so if you are going to like more of read operations, if you are going to query it out more kind of data, apart like when comparing to your writes, which in the case the entry which you are going to insert into is less, and your select star from or select is going to be very very high. In the case you can go into MongoDB. If your application is going to have large number of writes, a very very large number of writes, you can go into this one, because the write in MongoDB is little slow when comparing to your RDBMS. Okay, on that case you can go into MongoDB. And apart from that, if you don't have particular if you don't have major of joins, and like you have like a plain DB, like a simple DB like kind of stuff, you can go into kind of a MongoDB. Okay, this is where the scenario you should go into a MongoDB. And these are going to be purely dynamic based on your user scenario. Okay, you should at least read once on yourself, like what is the difference between this MongoDB and kind of a RDBMS. Then you will get to know when to use MongoDB and when to use your RDBMS. Okay, and I hope this all are clear. This is like overview of what is a kind of difference between a kind of a non RDBMS and an RDBMS database. Clear with this one?
Yes, it's clear.
Okay, so few names in MongoDB. Okay, so there in kind of a RDBMS will call it as a table, right? What we call table over here is what we call as a collections. Okay, and then there we'll call it as a row. Here we'll call it as a document, and over there it is column. Over here it is field. Okay, these are the names which are changed, but basically these all are going to be similar for you. Okay, so in the session what we are going to see is we are going to see how to create a database, and then how to create a table inside that one, and how to insert some records into that, and how to delete some records, and what is a how to update some things, and filtering, and how to delete a table, and what else is there, how to delete a whole database itself. And then what else is there, and how to query it out, this filter kind of things are there, right? How to query it out few things from this databases. And then we can see how we can write aggregation queries and views, and then we can see about indexes. So these are the topics which you are going to cover for today. Okay, so I hope we can start now. So for any doubts? I'm just giving a pass here. So far, any doubts?
No, no.
Okay. Okay, then we can start. Okay, so first we'll see how to create a table. So table here is called as collection. So you can use a CLI or this kind of a GUI. So CLI is something difficult to use, so I mostly prefer to use this GUI. Okay, so you can see this create collection is there, right, which is basically similar to your table. So if you click on this create collection and wait, I am where or I will connect from start so that you'll get to know how it is going to look like. So when you open, it will be something similar looking like this. And if you click on fill connections individually, you can see it is running in my local host, and this is the port it is running. And I don't have any kind of a username and password for now. So it is showing no username and password so set over now. Okay. So when you installed MongoDB itself, it will run in your local host in this particular port. If you click on connect, it will connect a kind of a it will connect this DB for you. So it will connect into my local host 27 like 27017 port number. Okay. So now I will close this. Okay. So now what we are going to do is we are going to create a database over here. So I hope I have only 3 minutes. I will create only database. Remaining stuff we'll see after the call. Okay. So this is my database. Its name is going to give over here. What is the name which I can give? Okay. Maybe. So I'm giving some name, and what is my collection name? So we'll go with table itself. So collection is my table, and I have given my what is my database name. So inside this it will create a table called student, and it will give me the things. So if you want support for time series and other things, you can click on that. So on basic, you don't need anything. You can just create this DB. So you can see now my DB is created. So if I click on this one, can see my student table is created. If you click on the student table, so you will see like this collection has no data. So table here is called as collection. So this collection is having no data. So either we can do like we can insert data using JSON or kind of a CSV. Okay, these two options are available. This is how to create a database and a table. Okay, any doubts so far?
No.
Okay, I hope the call will be get it will be over by 6:50. So if I start, I will drop in the mid. We can connect again by 7 and we can start the remaining ones. Is that fine?
Yeah, it's fine.
Okay. So yeah, we'll connect again by 7 o'clock and then we'll start the topics, next topics.